Alright guys, I have some review problems here to work through. So I promised you guys an answer key, so while I'm making it, I'm also going to make a video. So if there are some answers that you don't know how I got, you can always go back and reference this video. So be sure you check the description below for a link to the PDF copy of this review here if you don't already have it. Otherwise, this is the problems I'm working through, so yeah. Alright, so number 1 says to describe the translations on y equals 2, x minus 1 squared plus 5. Well, we know what each of these numbers does, so the 2 would be a vertical stretch by 2. The 1 here is going to shift your graph to the right 1 unit, and the 5 is going to shift your graph up 5 units. Alright, so all I wanted to do on number 1 there was to describe the translations. Same idea here on number 2. In this case, we have a negative in the very front. That negative has its own translation. It's called a reflection over the x-axis. The 2/5 would be a vertical compression by 2/5. We also have a shift, in this case, to the left 4 units. That's the 4 there. And the shift down 7 units. Okay. 2 problems down. Alright. Number 3. It says, given a parabola with a vertex at -3, 1 and a point at -1, 4, find another point on the graph. So I'm going to do this graphically. If we know where the vertex is, then we also know where the axis of symmetry has to be. So if our vertex is at -3, +1, it's right here. And we also have a point on the graph at -1, 4. Okay, so if I know where my axis of symmetry is, I can reflect across it and find more points on the graph. So if I go over 2 units to the axis and then I go over 2 more units, I'm going to have a point on the graph at -5, -4. Okay, you have enough information there to solve and find the formula for that if you would like to find another point, but why waste the time? So on number 4, though, we need to find the formula because that's what I asked for. It says write the equation of the parabola in vertex form with a vertex of 4, 3 and a y-intercept of -2. So we know our vertex, that's your h, k, is given as 4, 3. And we have a y-intercept. That's going to be an x and a y, a point on the graph. If it's a y-intercept, the x value is 0. And they told you that the y value was -2. So vertex form looks like this. Y equals a times x minus h quantity squared plus k. So we're going to plug in our x and our y and our h and our k and try to solve for a. So 0 times -4, or 0 minus -4 would be -4 squared, would be 16. Moving the 3 over by subtracting it, and then dividing by 16. A would be -5/16. So then your equation in vertex form would be y equals -5/16 x minus 4 squared plus 3. So you're only going to plug in a, h, and k. Leave the x and the y as variables. Okay, so there would be your answer on that one. Go ahead and circle my answers up here, or boxed in. Okay. On number 5, it says to find the vertex for f of x equals -2x squared plus 8x plus 3. So if you want to find the vertex, Well, we know that the x value is at negative b over 2a. This is also how you find the axis of symmetry. So negative 8 over 2 times negative 2, which would come out to be 2. So that's your x value of your vertex. So if you plug that back in, you can solve and find specifically what is f of 2. In other words, if you plug in 2 for x, what do you get out for f? So 2 squared plus 8 times 2 plus 3. Well, 2 squared would be 4. And 8 times 2 is 16. So negative 8 plus 19 would be 11. So it appears that the vertex here, the x value is 2, and the y, or the f value in this case would be 11. So your vertex would be at 2, 11. Answer. Part B there, 5B, asks, is the vertex at a max or a min? So in this case, notice that our a value here was negative, which means that the graph is going to open downward. So we would have a maximum. Okay, so 5B, the answer is max, because the graph opens down. Alright. Number 6 says find the x-intercepts. 2x squared plus 5x minus 12. So to find x-intercepts, that's where y, or in this case f, is equal to 0. And what we want to end up doing is factoring this equation. So 0, and we're going to try to factor this. So we know 2x and x give you 2x squared. And 4 and 3 would give me 12. And positive 8 minus 3 would give me 5. So 2 times 4 gives me the 8x. Negative 3 times x gives me the negative 3x. And that would give me the 5x in the middle. So I know that I factored it correctly. Alright, so then to find the x-intercepts, once you have it factored and set equal to 0, you're going to set each of those factors equal to 0. And then solve for x. Okay, so adding 3 here, and then divide by 2. Or in this case, subtracting 4, and you have your answers. Okay, so one of our x-intercepts would be at 3/2, 0. The other one would be at negative 4, 0. Okay. Number 7 is the same idea. You want to find the x-intercepts. But in this case, your formula looks a little bit different. It's just x squared plus 9. So in this case, there's not a linear term here. And you may notice up front that this doesn't factor. But in this case, we don't need to factor because we don't have a linear term. We don't have just an x. We have an x squared. So in this case, we're going to subtract 9 and then take the square root. The square root of x squared is the absolute value of x. So then the square root of 9 would be 3, and the square root of a negative is I. And absolute value, of course, can be positive or negative. So we get x equals plus or minus 3i. So one of them would be at 3i, and one of them would be at negative 3i, 0. Alright? Number 8, same idea. It says to solve the equation. But they give you the problem, and it's already in factored form, which is awesome because it makes it much less work on our part. So if we have a bunch of factors set equal to 0, well, then we can just set each one individually equal to 0. So here x would equal negative 1. Here x squared would equal 4. So x would be plus or minus 2. And here x would equal 7. So the only thing that I'll elaborate on here, x squared equals 4. Again, when you take the square root of both sides, the square root of x squared is the absolute value of x, and the square root of 4 is 2. And it's the fact that we have absolute value here that makes you have two solutions. Okay, So your solutions would be x equals -1, x equals plus and minus 2, and x equals 7. Okay. And then number 9 here, and then I have to go to a new sheet. 24 equals -11x minus x squared. So in this case, we want to get everything on the same side because it's quadratic. So I'm going to add x squared and add 11x so that I have my right side equal to 0. And if I want to solve for x, I need to factor this. So that would be x plus 3 and x plus 8. And then set the factors equal to 0. X plus 8 equals 0. So x would be -3 and -8. Okay. So there's 1 through 9. I really want to keep it all on the same sheet so I can just scan it in to make my answer key. So number 10, coming up here, we have f of x equals -2x squared plus 4x plus 3. So the directions here say that label the vertex, the axis of symmetry, and 2 points on the graph, and then actually sketch and make the graph. So the axis of symmetry is x equals minus b over 2a. So that would be -4 over 2 times -2, which is +1. So we get x equals 1 for the axis of symmetry. If I go back and plug that in, well, I'm going to get -2 plus 4 plus 3, which is 5. So I plugged in 1 and I got out 5. That's my vertex. 1, 5. And then 2 other points on the graph. Well, I can find my y-intercept really easily. Let's plug in 0 for x. So 0 plus 0 plus 3 would be 3. And then again, if my vertex is at 1, then I can reflect that y-intercept over. I would also have a point at 2, 3. Okay, so those are probably the two easiest to find since this won't factor. And then we can make our graph real quick. So x equals 1, 5. 1, 2, 3, 4, 5. And a y-intercept is at 0, 3. And we have a point at 2, 3. Notice this is working out great because the graph should open down since it's negative in the front. So our quadratic would look something like this. And then one more problem on this page, and then I'll pause the video and probably start over. I'm going to split this up into a couple different parts. Although I don't really want to upload 17 different videos, so I may split it up on after the second page. Same idea here, only this problem is in vertex form, which makes it go a little bit faster. So the axis of symmetry, in this case, would be x equals 1/2. It's this number right here, your h value, if you will. Your vertex would be at 1/2, -7. So it's the axis of symmetry and then k on the end. And then your 2 points on the graph, well, we're going to find those once we go to graph it. So I'm not going to do this algebraically. So let's start sketching our graph here. Going over 1/2 and down 1, 2, 3, 4, 5, 6, 7. Okay. So notice here we have this 1/2 in the front. That's a vertical stretch by 1/2. So to get more points on the graph, we're going to go over 1, and then we'd go up just a 1/2 unit. Normally, if this half wasn't here, you'd go over 1, and then 1 squared would be 1, so you'd go up 1. Or you'd go over 2, 2 squared would be 4, you'd go up 4. But in this case, we have the half in front, so that's going to multiply our y values, how much we go up and down, by a half. So if we go over 1, we're going to go up a half. Or if I go over 2, I'm going to go up 2. So over 2, which would put me at 2.5. And then up 2, 2.5. And that would put me at -5. Or if I do it in the other direction, that put me at -1.5, -5. Okay, so 2 other points on this graph. These are not the only 2 points that you could find. They are just the 2 that I happen to go for. 5 halves, -5, and -3 halves, -5. You could also try to find the y-intercept by plugging in 0 for x. So you'd get -1/2 squared would be -1/4, or +1/4, times the half would be +1/8, -7 would be -6 7/8, which is horrible numbers to work with. So I think it's easier just to use the translation, since you're going to have to do it anyway, and then make your graph. So notice that this graph looks like it's wider than this one, and it should, because we had a vertical stretch here, or a vertical compression, which makes your graph fatter, versus the vertical stretch over here that makes your graph skinnier. Alright. Yeah, let's go ahead and do the back of the sheet too. Alright, so let's continue on to the back here. Number 12 says, which of the following is, or are, if there's more than one, quadratic? So, number 1 is y equals 5x to the -2 minus 9. I'll have an eraser. Option number 2 would be y equals 2x minus 1. And option number 3 would be y equals -3 x plus 2 quantity squared. Alright, so option number 1 here, by the way, this is number 12, is not quadratic because of the negative exponent. So, no. Option number 2, this is also not quadratic because there's not a squared anywhere in there. But option number 3 looks good because of the square. Notice this is vertex form, so it's pretty obvious that's a quadratic. So on a multiple choice thing here, that only 3 was the one that works. That would be option number C on this test. Okay, on this review. Alright, number 13 says y equals 2x squared minus 8x plus 4. Write it in vertex form. I mean, it's a multiple choice question. So, looking at the answers, almost all of them have the same h value, or that would be the axis of symmetry. So I'm going to solve this one by completing the square. The first thing I'm going to do is factor a 2 out of those first 2 terms. Leave the 4 over here the way it is. Take half of my middle number, which would be 2, and square it. That'd be 4. I'm going to add a 4 here. But notice that I really added 2 times 4. This 2 is going to multiply. So I really added 8 just now. So to balance my equation, I'm going to take away 8 from the end. And in doing so, this thing will now factor as a perfect square. I'm going to get y equals x minus 2 squared minus 4, which is option B on the multiple choice. Alright, and then number 14 is hard to replicate, but for quadratic regression, you're looking for something that looks like a quadratic. Either it's going to open up, or it might open down. So, looking at our scatter plots here, well, this one looks kind of linear. This one looks like something that we'll talk about as we get to the end of Algebra 2. This is a sine graph, or a cosine graph. This one, though, appears to be pretty quadratic, so I'm going to go with option B. Okay. Then we have a matching page here. So we want to match up these equations with our graphs. So on number 1, again, we're looking for something that goes up 1, left 1, that opens down because it's negative in the front, and that is really skinny because of the 3 there being a vertical stretch. So left 1, up 1, opening down, and skinny probably is going to be E. Okay, so 15 is E, 16. Another skinny one. This one's going to open upward though. It's been shifted to the right one and down one. So right one, down one. But that one's fat. Right one, down one. It opens up and it's skinny. I'm going to guess that one's A. There we go. Okay. This one's going left one, up one, opening up. It's skinny because of the 3. Left one, up one, and skinny. That'd be option C. I probably can't even see where I'm writing this stuff down. My bad. 18, 19. So 18 is up one, left one. It's opening down because it's negative. And the 1/3 is going to be a vertical stretch by a 1/3 to make your graph wider. It's one of these two. So if you're going left one and up one, left one and up one, that would be option D. Left one, up one, and then opening down and wide. Option D. And then number 19 here, negative 1/3. That's also going to open down and be wide, but it's going to the right one and down one. So that would be option B. Okay, another page down. And here we're getting into the stuff that requires a calculator. So I'm going to stop this video here, go grab my calculator, and then look out for part number 2.